Right now, off the coast of Genoa, Italy, construction crews are deliberately sinking buildings into the Mediterranean. While this may sound like madness, it's actually one of Europe's most elaborate maritime construction projects, and part of an attempt to redraw one of the continent's most important ports around the modern global economy. Each building is in fact a hollow concrete caisson, more than 30 meters tall and nearly 70 meters long. They're each pulled into position by tugboats, their internal chambers are then slowly flooded, and over the course of hours, they eventually disappear beneath the surface. One by one, they're gradually becoming part of a new breakwater, one that will eventually stretch more than 6 kilometers across the sea. But while the physical task may be extraordinarily complicated, the reason for doing it turns out to be brutally simple. Today's container ships have grown so large that Genoa's existing harbour has become too cramped for many of them to enter and maneuver easily. And because the city is trapped between the sea and steep mountains, there aren't many directions in which to expand the port. So, Italy has opted to move the edge of the harbour itself, hundreds of metres farther offshore, in the hope that larger ships carrying more of the world's trade will follow. In this episode of Looking For, we'll examine why Genoa is making such an enormous bet on its port, how engineers are building a structure of this scale in deep water, and what it could mean for the flow of trade through Europe. Because beneath the spectacle of sinking concrete giants lies a much bigger question. Can rebuilding the entrance to one port reshape an entire continent's connection to the world? The importance of Genoa's port to European trade is recognizable, even if all you do is simply look at a map. It sits at the top of the Mediterranean, but even more so than that, it sits at the bottom of a hugely consequential swathe of Europe. Across countries like Italy, Switzerland, Germany, Belgium, and the Netherlands, there's an immense concentration of cities, along with many factories and consumers. Genoa is also one of the southern endpoints of the Rhine, Alpine Freight Corridor, a vast rail network connecting the Mediterranean with some of Europe's most industrialized and densely populated regions, and eventually with the enormous North Sea ports of Rotterdam, Antwerp, and Amsterdam. Genoa's position should theoretically be appealing for trade arriving from Asia, as it offers the opportunity for ships emerging from the Suez Canal to turn north and reach Italy without making the much longer journey around Spain, through the Strait of Gibraltar, and up toward northern Europe. In fact, the European Commission even concluded after a 2016 study that Mediterranean ports have a natural maritime advantage on the Asia-Europe trade route. But oddly enough, much of Europe's maritime trade has traditionally taken the longer route, through the Strait of Gibraltar and upward toward northern ports such as Antwerp, Bruges, Rotterdam, and Hamburg. Part of the reason is that these northern ports sit at the center of enormous logistics ecosystems, with expansive terminals, inland waterways, highways, and railways capable of distributing cargo across the continent. As a matter of fact, the northern system has become so dominant in European maritime trade that the 3 ports I mentioned are the 3 largest ports by cargo volume in all of Europe. Genoa's problem is that its promising position on the map conceals an extremely difficult geography. The city occupies a narrow strip of land between the Ligurian Sea and the Apennine Mountains. Its waterfront is already crowded with port facilities, roads, railway lines, and dense urban development. Moving cargo inland almost immediately requires it to climb through, or increasingly tunnel beneath, steep and mountainous terrain. To compete, Genoa must create a reliable route to carry cargo out of the harbour and into the rest of Europe. That's why, for example, Italy's National Railway Infrastructure Manager, RFI, is developing the Terzo Valico dei Giovi, a high-speed railway project intended to improve the connection between Genoa, Milan, and the wider Rhine-Alpine corridor. But neither this high-speed rail nor any other investment will amount to anything unless Genoa first solves its most immediate problem, which is that the port itself is simply too small. Over the last several decades, shipping companies have increasingly turned to larger container vessels, primarily to cut costs. According to the United Nations Conference on Trade and Development, the average size of container ships has more than doubled since 1996, while vessels capable of carrying more than 20,000 standard containers have become a significant feature of the global fleet. Larger vessels require deeper water, wider entrances, longer berths, and enormous areas in which to slow down, turn, and maneuver. They also unload vast quantities of cargo at once, placing additional pressure on cranes, terminals, railways, and roads. Genoa cannot move the mountains behind it. It cannot easily clear away the city surrounding it, and it cannot persuade the global shipping industry to just revert back to smaller ships, no matter how politely it might ask. And when you've ruled out all possible solutions, the remaining solution, however improbable, must be the one. So, in the only direction that's even available, the port is expanding out into the sea. In Genoa's case, the most important step is moving the wall that defines the harbour, the breakwater. Breakwaters act as barriers between ports and the open sea beyond them. By absorbing and redirecting the force of incoming waves, they create calmer water, allowing ships to approach terminals, maneuver safely, and remain stable while cargo is transferred. But Genoa's existing breakwater also places a hard limit on the amount of protected water available inside the port. This matters because a modern container ship does not simply need a berth long enough to accommodate it. Vessels measuring more than 400 meters from end to end must first pass through the harbor entrance, slow down, and rotate with the assistance of tugboats before they can approach a terminal. If you imagine a skyscraper lying on its side and how much space it would need to be able to rotate freely, you get a sense of the magnitude we're talking about. As stated earlier, Genoa's final configuration will see the new breakwater stretch a whopping 6 kilometers out to sea. That's so far from shore that it would take you nearly an hour and a half to walk that same distance on land. In truth, it's almost more accurate to describe the new breakwater as carving out a large lake in the ocean, where waters will be calmer and steadier. The first phase of construction will create a new entrance on the eastern side of the port, measuring 310 meters across, while substantially enlarging the area available for ships to maneuver. A later phase will widen the channel in front of the Sampierina terminals to approximately 500 meters, improving access through Genoa's main commercial basin. This will allow the port to receive container ships more than 400 meters long and 60 meters wide, along with the newest generation of enormous cruise ships, granting them a turning basin that is 800 meters in diameter. For reference, according to the Western Ligurian Seaport Authority, this will mark a 45% increase from the current turning basin's diameter of 550 meters. The scaling of the entrance and navigation channel is even more dramatic. The current navigation channel is narrowed to just 150 meters, meaning the new channel will more than double its predecessor. Compounding the challenge of building all this is the fact that it all must be done while Genoa, in its current form, remains operational. The new barrier is being assembled beyond the existing one while commercial ships continue moving through the port. As sections of the new breakwater become usable, the harbour can gradually be rearranged around its new entrances and manoeuvring spaces. On a map, the logic appears straightforward. Move the wall outward, create more room, and then simply open the port to larger ships. But what works neatly on a map becomes considerably more difficult beneath the surface. By moving into the open Mediterranean, the project reaches water substantially deeper, as deep as 50 meters, or roughly the height of a 15-story building. And at the bottom of that water lies a layer of marine sediment far too weak to support a 6-kilometer wall without extensive preparation. That preparation has already become one of the largest parts of the construction effort. While crews sink the concrete caissons along completed sections, other teams are still strengthening the seabed and assembling the vast rock foundation farther along the route. The process begins by driving tens of thousands of compacted gravel columns into the weak marine sediment. Specialized probes called vibrafloats descend from floating platforms and vibrate their way into the seabed. As they rise, the surrounding gravel flows in to fill the space they create. That same gravel is then tightly compacted into vertical columns as tall as 13 meters. The process is then repeated tens of thousands of times. These gravel columns strengthen the surrounding sediment, improve drainage, and reduce the risk of the immense structure above settling unevenly. Crews then cover this improved seabed with an enormous foundation of gravel and rock. Altogether, the completed breakwater is expected to require roughly 9 million tons of stone, some quarried in Italy and Spain, and some reused from the old breakwater as it gradually gets dismantled. Once a section of improved seabed is covered with the gravel and rock foundation, the next step is to add one of the hollow concrete caissons. These are cast at a floating production site off the coast of Var de Ligure, 40 kilometers west of Genoa. The largest of these three structures measures 33 meters tall, 30 meters wide, and 67 meters long. Therefore, they need to be hollow in order to remain buoyant while tugboats maneuver them into place. Even hollowed out, They weigh as much as 10,000 metric tons. The caissons are divided internally into many hollow compartments. Crews then flood the separate chambers one at a time in a controlled sequence, slowly lowering the entire structure until it rests on the prepared foundation, as far as 50 meters beneath the surface. The concrete itself has also been specially formulated for this environment. Seawater can gradually penetrate ordinary concrete, allowing chlorides to reach and corrode the steel reinforcements inside. For Genoa's caissons, engineers at Heidelberg Materials, Italy, developed a more impermeable mixture, intended to slow that process and withstand decades of exposure to salt water, waves, and changing weather. Some of the concrete is produced by a dual batching plant, mounted on a floating barge about 800 meters off Genoa's coast. During the day, it supplies concrete directly to crews constructing the upper sections of the breakwater. In the evening, it returns to ports to reload raw materials, all while operating on a platform constantly moving with the wind and waves. This is a unique innovation, requiring a delicate balance between human-made technology and the forces of nature. Once a caisson reaches the seabed, its flooded internal chambers are filled with rock material, adding the weight that permanently anchors it in place. Crews then complete its upper structure and add the seawall that will absorb the force of incoming waves. This sequence is currently being repeated all along the route. As of June 2026, 24 caissons have been installed, and the emerging breakwater had extended beyond its first kilometer, while foundation construction continued farther ahead. Eventually, more than 70 of these concrete buildings will stand side by side, most of them almost entirely invisible, forming a new boundary between Genoa's harbour and the Mediterranean. Inevitably, a project of this magnitude will also affect the marine environment. The biggest risks are altering local currents and disrupting seabed habitats, and there's an extent to which a project this large simply cannot avoid causing such environmental disturbances. However, to minimize the damage, crews are taking various carefully calculated steps, which include tracking water quality, monitoring marine life, relocating sensitive corals, and conducting visual and acoustic monitoring procedures for any dolphins or whales along construction routes. Delivering all of this is the Genova Breakwater Consortium, a group of major European contractors led by the infrastructure company WeBuild. The main consortium contract is worth €843 million, while the European Investment Bank estimates a total Phase A cost of €937 million. The consortium shares are divided variously among its 4 participants, with WeBuild taking the lion's share of 40%, both Fincasit and Fincantieri Infrastructure taking 25%, and Sidra, part of Belgium's Demi Group, taking the remaining 10%. That makes this one of the largest investments ever made in an Italian port. But of course, ultimately, the value of the breakwater will be measured by the ships and cargo it can attract. And that won't just depend on the harbour itself, as already mentioned. It will also depend on the surrounding transportation infrastructure and whether it can compete with northern systems such as those in Antwerp, Rotterdam and Hamburg. However, assuming all the pieces do come together, the impacts could extend far beyond just the Ligurian coast. According to WeBuild's estimation, Genoa sits roughly 1,000 nautical miles, or close to 2,000 kilometers, closer to major Asian ports than its competitors in northern Europe. This means, for example, that Genoa could be as much as 5 sailing days closer for Asian hubs like Shanghai, Yokohama, and Singapore. According to projections publicized by the builders and attributed to Genoa's Port Authority, the completed breakwater could help commercial traffic through the port grow by between 22 and 30% from 2027 to 2030. Over time, the authority estimates that the additional container revenue, port charges, and taxes enabled by the project could generate approximately €4.2 billion in economic benefit. For now, though, that future remains hidden beneath the Mediterranean, taking shape one sunken caisson at a time. The first phase, opening the new eastern entrance and expanding the maneuvering area, is currently scheduled for completion in 2027. The second phase, including the full widening of the Sampierna Channel, is planned for 2030. Only when the world's largest ships begin choosing Genoa will we know whether this was simply an extraordinary feat of engineering or the moment Europe's trade map began to shift south. Thank you all for watching this video. If you enjoyed this story about a city betting big on infrastructure to try and emerge more on the global stage, you'll definitely want to check out our video on the new Addis Ababa mega airport in Ethiopia, which the country is spending 10% of its total GDP just to build. That's all for now. and we'll see you next time on Looking For.